Good afternoon, students. This is video 2.4 and of logic lines, and your objectives are: I can use inductive reasoning to make conjectures, and I can determine counterexamples for statements. The IQ skill that I want you to work on is I2. So that is an I here. That's an I. Please make sure that you get this skill done. It is not due tomorrow, but you should have it done the next time that I see you, okay? Which will be after break. Hooray! All right, so let's go, flippers. The first thing we want to talk about today is inductive reasoning, okay? Well, inductive reasoning is simply think about something for a moment. If I were to ask you to look at this first picture here, it's a box with 4 smaller boxes inside of it in different colors: green, blue, red, purple. So here, if we look at the next box, we've got blue, red, purple, green. The next one, red, purple, green, blue. The next one, purple, green, blue, red. I had to make another box and say, hey, do you know, can you predict what would happen next? If I had to guess, I'd say that green, blue, red, purple would come next. And it just so happens that that's exactly like this first one. So I just used inductive reasoning, okay? So inductive reasoning is reasoning based on patterns you observe. And that's a pattern here that we saw. So let's look at this example. It says, look for a pattern. What are the next 2 terms for the numbers 20, 30, 40, and 50? And you probably guessed right. Looks like this is going up by 10, going up by 10. So that would be 60 and 70. And if we were asked to go back, we could say that this started at maybe 10, or even 0, or even negative 10, because we can clearly see the pattern and where it's going, 50. Another important term is conjecture. And this is probably where you've heard, but maybe not in a math class. A conjecture is a conclusion you reach using inductive reasoning. So if we have this example, it says, what conjecture can you make about the 21st term in the pattern 0011, 0011? I can use inductive reasoning to make a conjecture. So it appears that the first 2 terms are going to be 0. The next 2 terms are going to be 1. And then that pattern repeats. So if I look at this pattern repeated over a period of 5 times, I'll be at my 20th term, which would be that means the 21st would be a 0, because I'm going to have 5 times a repeated pattern of 0011, 0011, 0011, 0011, 0011, and then that next term again would be 0. Counterexample is another term that's really cool and kind of important, and it's an example that shows if a conjecture is true. So this is like you trying to find that one thing that proves something to be false. So an example is, what is a counterexample for each conjecture? So it says, if the name of the month starts with a J, it's a summer month. All right, so let's just think of all the months that start with J. All the months of the year that start with a J: January, June, and July. And it says, it's a summer month. Well, that actually happens to be true for June and July. But January, folks, is not a summer month, so that is a counterexample for this conjecture. Our first example says, what is a counterexample for each conjecture? So it says, you can connect any 3 points to form a triangle. There are clearly 3 points that connect to make a triangle, but what about these 3 points? If we make C, D, and E 3 points on the same line, then these 3 points cannot connect to make a triangle. No matter what I do, I cannot connect these to make a triangle. So here, here. This is not a triangle. So that doesn't work. So we cannot connect these to make a triangle. So this is my counterexample. Number 2, it says, what is the counterexample for the statement below? Angle 1 and angle 2 are supplementary. So one of the angles is acute. Here's an example of how this statement is true. Here, angle 1 and angle 2 are supplementary as to 180, and one of these angles is acute. But what about this? What if angle 1 and angle 2 are both right angles? Right angles are not acute because they are larger than 89 degrees. They're equal to 90. So this is a counterexample. Here's your secret question. It says, the graph shows the water level of a local swimming pool as it fills over several hours. What conjecture can you make about the water level after 5 hours of filling? Explain. So over here on the left, they're going up by 2s. 0, 2, 4, 6, 8, 10. And over here, it's going up by 2s. So what do you think after 5 hours? Right around here. What is your conjecture? All right, so that is it for tonight. Please make sure you answer your secret question. And remember to work on Excel skill I2. Remember, that's an I. That's an I. I2. Thank you.